Question 1935 is a very straightforward question, but it does require some explanation to understand it. We're asked in this question to find RB. What this is it's the impedance that we would see if we were looking into the base of the resistor. It's what we would see looking into it. Now, why is this value important? Well, remember we said that this point over here, this voltage and the voltage divider, can be easily calculated as R2 over R1 plus R2 times 30 volts. And that is true if the impedance RB is very high. If it is at least 10 times greater than R2, then we can essentially ignore it. Another way of looking at it is saying if RB is very high, then it means that the base current must be very small, and therefore we can effectively ignore it as well. So, how do we go about calculating RB? This number HFE, 150, is the same as beta. And that is the gain of the current gain of the transistor IC over IB. And because of Ohm's law, if you multiply the current that much, you actually multiply the impedance by that much as well. So we take a look and say, what is the impedance seen from the emitter, which is basically the output of the circuit, and we see that it's simply this emitter resistor over here. So the net result is that RB, the impedance looking into the base, is equal to the current gain, HFE, times RE. So in our case, this is equal to 150 times 1K is equal to 150 K ohms. So again, remember what this means. Looking into this path, the resistance looking at the base is about 150,000 ohms. That is so much larger than 5K that it can be effectively ignored and taken right out of the circuit, which means that we're left using the simple voltage divider rule. Having 150 K ohms in this branch effectively means that the current in the base is going to be very small, and therefore we can assume that IC and IE are essentially the same.